Y'all can see my screen, yeah? Let me have the chat box here. Yay, okay. So if you have already done this part, you can use the time you have during the lab to do everything that's not done yet for your second assignment. Otherwise, as usual, you can proceed as I progress and as I do the different tasks of part B. So let me have the assignments description here just to take a look really quickly. So in part B, we will be working with the other data set. Okay, so the other data set is pretty much similar to the example that you had last week here in your lecture. To have a reminder on that, I also have your lecture from last week, which was finding a model to predict what's converting the users. Okay, so there we talked, actually others talked about logistic regression and having a model to how to evaluate the model that we develop here. So the example that you were taught last week is pretty much similar to what you have in this assignment. So we have, let's have here subscription. So we have the sign updates. We have first session. We have the device type similar to the previous one. Count retire similar to ABSAE. We have referral sources where they came into the platform for the first time. The number of sessions in the past 30 days, total time spent in the past 30 days, number of projects created in the past 30 days, number of expert collaborators, support tickets in the past 30 days, AI assistance sessions, and the premium features that they have used so far. So this is an overall look at the overall overview of the data set we will be working for the part B. And so we're going to begin with just evaluating the data set, doing a bit of feature engineering, which I will be doing shortly. We're going to do a bit of EA. I am not going to go into the details today. I let that part up to you. And then at the last parts, B3, B4, we're going to be doing logistic regression, and we're going to be using statsmodel. So among the features, before we begin, I would like to actually ask about the features you think we can define for this data set. So I know that we've already defined some of them in the scaffold, but I would like to hear your suggestions. What are the features you would like to create? We technically have them in the reading. I just want to know what you are curious about. Referral source. Okay, that's good to start to begin with. Just let me have this data here. So what else would you like to know based on the data set that we have? Use premium feature preview. Certain stuff recorded throughout the 30 periods, like collaborators invited and support tickets. Yeah, that's good. Yeah. That's good. let's see use premium feature preview column. That's gonna be this one here. Okay. So it shows whether they have used premium feature preview or not. Okay. Exports normalized over time. Yeah, that can also be a good feature. Yeah. But again, there's no right or wrong answer. You can pick whatever you want. I'm gonna proceed with some of them. We have told you to find some of them in the project description. I just wanna know your takes of it. So, what we're gonna do, what I'm actually gonna do, is that we will have the number of days to the first session. So the interval between their sign up date and their first session date. I'm also interested to know, like, it's kind of similar to what Eti said, but I would also like to know the average session duration. Okay, so that is the total time divided by the number of sessions. I'm also interested to know whether they have signed up on a weekend. Okay, I would like to know, and more importantly, because we're gonna have some sort of classifier, I would also like to turn categorical columns into numerical ones. So we're gonna have some dummies as well. Okay, so we're gonna do them one by one. First of all, let's double check that we have our dataset ready. Okay, I have to. Oh, I should be here.
Yeah, I should be.
Good. Alright, so I have to run this to make sure all the libraries are here and available. Okay. And then scroll down, way down to cards. So, okay, so we have our dataset ready. I hope the text let me just, okay. Now we have more for the text. Okay, so we have our dataset, user ID, sign up date for the session data, a couple of the first rows of the dataset, so it's imported properly. Oops. And okay, yeah. We also see that we have 3,000 users. Some of them are duplicate. We're not gonna go to data cleaning and stuff. So to take a look at the number of sessions, on average, the mean of number of sessions is 925. They have spent around 216 minutes in the past 30 days. Around 2.5 projects has been created. Around 2 experts has been done. So we have a general understanding of the dataset here. So let's go to the feature engineering. I'm gonna write a couple of lines, and then I won't be spending a lot of time for the feature engineering. I'm gonna just copy paste them because we're gonna get to the more interesting parts of the lab, which is B3 and B4, logistic regression and evaluating logistic regression. Okay. Over here. Okay, so we would like to have sign up dates. We want to transform it into a more proper format to date time. Sorry. history. Punch to datetime. If sub sign of ish. Okay. It's usually suggested to apply these like transformation type changes after you have cleaned your data set, okay? Because you might still have some oh yeah, my bad. Thanks. But still my muscle memory tells me to work with DA baby from previous weeks. Thank you so much. Yeah, so it's recommended to do the transformation, entire transformation after you have cleaned your data set, because you might still have some like invalid cells, like similar to the previous assignment. Some of the beginning and end dates might not match, so you might have like a first session actually being before the sign up date, which is against the sanity check. But I'm not gonna do them here today for the sake of minimizing the length of the lab. So then I would like to know the number of days to the first session. Okay, so I'm gonna add a new column, which is days to first session. Days to first session, yeah, which is equal to a simple arithmetic, which is subtracting. We have like first session date, and we're gonna subtract sign up dates from it. Okay, sign up dates. Sign up date, okay. And since it's a daytime object, I'm only interested in the number of the days. We're also we also wanted to see average duration session. So this would be like there is a edge case here. If they haven't had any sessions in the past 30 days, okay, so that's gonna make it trouble, because this is what we're gonna do. We're gonna add another df sub. We're gonna add another column, which is average session duration in minutes, which is df sub total time in divided by number of sessions in 30 days. Okay, but there's a problem here, as I told you. If a row doesn't have any sessions in the past 30 days, if the user doesn't have any sessions, this value will be equal to 0. And this expression here would return an error, not assigned. Okay, we don't want that, because it will mess up with all the calculations that we're gonna do. So we're gonna add a condition here at the end, at the beginning of the function, so the where actually exists for this same reason. We're gonna say, so number of sessions in the past 30 days, if it's equal to 0, then you're gonna set 0 to it, 0 in this field. Otherwise, you put this here. Okay, so I was also interested in knowing whether they have sign up during the weekend. Okay, so I'm gonna say is maybe we have decided in Figma to have our campaigns on weekends, so we want to see how many of them signed up during weekend sign dates. This is a daytime object, so I'm gonna get weekday and I'm gonna check whether it's actually in 5th and the 6th day of the week. Okay, so I'm gonna turn it into the weekday. I'm gonna check whether it's in this set, which is Friday and Saturday, and I'm gonna turn this boolean into integer so that instead of true or false, I get 0 or 1. And then we're gonna have our dummies for the device, for referrals, and we're gonna have encoding for country tires as well. Okay. So device dummy is gonna be equals to the pandas get dummies. This time we're gonna be working with the DS sub instead of DFAB. And I'm gonna say, okay, get the device type field for me. Set the prefix to device. Sure. First. And then I'm gonna have referral dummies. Referral source. And then for the country tires, so here, instead of like in contrast to the A/B test datasets, we don't have continents. We have tires here. So tire 1, 2, 3, and I'm not sure how exactly this tire is made, but we can guess that it's probably based on the income rate in the markets. Okay. So in some countries, the customers, the users are more willing to spend money on the platforms. So that's gonna be something influencing the user's behavior. Country tire, we need a new field. So we're gonna say this is an encoded version of country tire. Okay. And we're gonna map it to this dictionary here. Is somebody say tire? Let me double check. Yeah, tire underscore number. Okay. There we go. So let's put them together. Let's, for the final step, divide the columns into 2 different groups. One of them are raw numeric features, which is, I'm just gonna copy paste this. Already have it. Okay. And then the other columns engineered equals to these 4 that we have here. This, and this. Okay. And we're gonna concatenate. We're gonna use what I'm defining here in the next sections. We're gonna have the regression, the logistic regression. Except we're gonna ask pandas to concatenate these engineered features. So it's Can you scroll up, please? Yeah, sure. Sure. Okay, so we have raw numerics. We have engineer. Okay, and then we're gonna have the device dummies and referral deaths. Okay. And we're gonna have the subscription column in a single variable called var_sub. Subscribe. Okay. So let's run this and see if we have, yeah, sure. And it's error. So what do we have? A problem here. Here. Okay, this is a problem. Okay. Woo. Okay, just to show you what we've done here, I'm just gonna I have some like print functions to show you to double check what we've done here. So fortunately here in the X sub we don't have any null cells. Everything here is numerical, so we can do calculations on them. We don't have in text. We will be working with the feature matrix, and we can see we have 17 columns, which makes sense because here we had 15, and we added 2. We added 2 here, which makes it 17. And here we have features, which consist of the natural features based on the original data set. And those we have engineered ourselves, okay? So let's proceed to the EA, okay? To just have a look, we see that the raw numbers tell us that we have 20% of 20.8% subscription rate. So among 3,000 users, 625 of them are subscribed. And the balance here is 2,375 to 625. We're gonna have some visualizations here. I'm gonna type 1 and we can see what's going on here. I'm actually interested to see the subscription rate by referral source. Okay. So let's currently I'm gonna set it to one row, one column, but we're gonna change this layer. Text size equals to 15.4. Okay, so we're gonna take our data set and group the columns based on their referral source column value. Okay, we're gonna call this sub by ref df sub. That's scoop 5. We're gonna go down by referral source. So if they are subscribe, okay, we're gonna sort columns in a descending order. So descending is equals to the false. False. Sub by ref index. Sub by ref values. Color equals to dark blue. X0 dot set title subscription rates by ref source. Okay. Last sites layout. Okay, we're gonna have two other diagrams here, but let's see what happens if okay. Okay, so that we can see that there is a like we have sorted them in a descending order. Those who come from a referral, like somebody has introduced the product to them, they came to the platform, they are kind of more likely to subscribe. While on the other hand, if they have joined the platform from a paid ad, they're significantly less likely to buy a subscription. Okay, and this gives us a sort of intuition. Okay, since we've already done this multiple times, I won't be repeating the coding I had again. Okay, to have a more clear understanding of the numbers percentages here, I'm gonna add the percentage here. So the difference between paid ad and direct referral is 6%. Okay. We also would like to know what happens. Like if you can see in this data set, there was a field called used premium feature preview, which I think Tim pointed out. Yeah, Tim pointed this column here. We're also interested to know the effects of showing them a preview on their subscription behavior. Okay. So we're gonna do the same thing. We're gonna group them, group the users by their user streaming feature condition, and then we're gonna have two columns, and the bar chart will show us the difference between these two. So just by looking at this diagram here, this bar chart here, there is a significant difference in subscription rates when we show them a preview of the premium features that they can have. Okay. And lastly, I'm also interested to I'm interested to know something a bit more bizarre, which is if they have done exports in the past 30 days, has it actually affected their subscription behavior or not? This is not really intuitive to check this, but like I'm a curious person in the team. So yeah, I'm gonna just do it here. We're gonna have this the box slide here. The column is whether there's been an export in the past 30 days. We're gonna set this to dark blue. And we can see it together. So let's just zoom in. I can zoom in on the pictures. Okay. So there is a bit of difference here. Not that much, but kind of a bit of difference. So it seems that somehow they're like, if they have exported something in the past 30 days, it doesn't really show whether they were willing to subscribe or not. There's no significant difference between these two groups of the users. Okay. Now that we have you can do this further. You can check other features and other grouping, other categories as well. But this one here, this one here, is the one that I'm most interested in. So let's check the correlation matrix. We're gonna have the numerical features here. We already defined them here. Okay. Exports number of sessions without time, project created, experience 30 days, collaborators invited, support tickets, use premium features, assistance. Let me just copy paste it here. Okay. We're gonna have a numeric features list, which consists of these fellows here and these two. Okay. Actually, yeah. Yeah. Okay. It's just so we're gonna have the X sub numeric features. Give us the correlation here, and we're gonna use matplotlib to visualize it as well. Fix okay. We're gonna have a heat map as we've done before. We have the correlation matrix here as the input. We would like to have the annotations. Okay. Sorry, I thought I had a message on Discord. Okay, so we want to see annotations, two floating points. Two is a floating points. Color mapping, cool to warm, and a bit of adjustments. Sensor is equals to 0. Axis equals to axis we currently have. Live width equals to 5 to 6. Tile Cobitrix Officious. Okay. It's taking a bit of time. Let's interrupt again. Okay, when it gets this is slow, sometimes I have to restart the notebook all the way. Okay, let's do this again. And for libraries. Okay. 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 Now we have the heat map here. Okay, so apparently, this is out. Okay. So this is the heat map that we have here. Obviously there is a hard correlation between average session duration and the total time in the last 30 days because like this is the average of the very same thing here. Besides this, we don't see a really strong correlation here. At the same time, I don't want to just I would also like to see the real numbers as alongside the matrix that we have here. Okay, so we're gonna have pairs where R is more than 0.5. Okay, so I'm not gonna write the code for this because it's like pretty easy. And we can see that besides this, we don't have like a really strong correlation between the numerical features that we have here, right? Okay. Any questions so far? Everything is cool? Okay. So let's get to the more interesting parts. we can actually take a 5 minutes rest because I realized that it's almost 7:40 and we are here till 8:20. So you can take a 5, and then we can come back to see logistic regression. Yeah, that's totally all right. Actually, let's say here for these diagrams, you can be way more explorative and curious than me and do like multiple charts here, but it just like depends on you. Yeah. Yes, sure, at the B1. Give me a second. B1 is actually pretty straightforward. Exactly. Exactly. That's why we actually introduced these libraries to you because it makes life way easier. Way easier. Yeah, sure. Okay. Yeah. We gotta be more creative. Okay. Uh, okay, we're done with the 5 minutes. So let's get back to what we're doing. So we can have a super boring table here for the like model evaluation, general model evaluation based on the columns and features we have right now so far. Let me just share my screen. Okay, can you see my screen? Can you all see my screen? Yay, okay, cool. So, running this using, let me show you the library here. Using a stats model, we can have, like similar to this table here where we had for our oldest regression. We can have a really boring table here showing us coefficients and pseudo R square numbers, which gives us a sense of what's happening in our model. We have previously seen the coefficients we have here in this matrix. Here, I'm not gonna wait here on these numbers. I'm just gonna pass it, but we're gonna go towards a bit of more interesting stuff. So here from your lecture, you had a concept called odds. What was it? Surprising points. Odds and probability. Yeah, here. Odds, log odds, and coefficients. Okay. So we're gonna calculate the same thing if it helps you remember what you had in your lectures. What we're gonna do here is to compute averages for all significant predictors. Okay. So we're gonna define a variable, a list of a numpy list called odds ratios, and we're gonna ask numpy to give us parameters, exponentiate coefficients to get odds ratios. Okay, and we're gonna exponentiate the 95% confidence interval bounds. Okay, so we're gonna say our confidence interval is numpy gave us shit. Yep. Interval int dot comes equals to and we're gonna combine this into a one table. We have a dictionary here. Okay, after that, we have our data frame. Understand data frame. We're gonna filter it to only keep significant predictors only. Okay. Okay, so we're gonna say in the OR table, okay, we want those rows where p-value is less than, okay. Okay. Then we're gonna sort these in a descending order. Sort values in a ratio. Ascending equals to false. And then we're gonna have significance that's round up to 4 decimal points, and we're gonna have them to transform into string. Okay. So let's take a look at this. Okay. And I would like to ask what you understand from this. Even if you don't have any idea, you can like just throw suggestions. Are you with me, guys? Okay. Tim says use premium features has a large effect on conversions. Okay. Okay. I think the name you have here is a famous baseball player, but Mason says all of these features are statistically significant. Kind of. Yeah, kind of. But like some of them, like let's say use premium features is way more significant. Okay, way more significant. Yeah, and we can see the difference that it's making. Okay, compared to like these other ones. Okay, and this actually matches the intuition we had based on these visualizations. So let's say here, what we could understood from this visualization here is actually kind of shown in numbers here as well. And the country tire, which had a descending effect on subscription rate, can also be shown with the numbers here, okay? So now the confidence intervals cross 1, which is mechanically guaranteed by the filter we had, this filter we had here, okay? But it's worth knowing that this table is a subset, okay? The non-significant predictors aren't failure of the model, okay? Their effect is just like more like a noise, okay? But to or to sort them in a descending order, we can see that this one is the most, it is the one with the most impact.
Oh,
Yeah, odds ratios and effect size. Okay, so let's proceed with the next part. We're gonna see the same thing, same we're predicting the subscription. Okay. We can also see the same thing using a visualization here. Okay. I think it's a good idea to skip it because like we have done lots of visualizations so far. Okay. I'm just gonna put the code here because I've already done it in the weekend. So I'm just gonna show you the chart here for the sake of seeing it. Oops, I pasted it in a markdown. So, okay, so technically, what we saw in the table here, we can see it here in the visualization. Okay, and to we can actually do it in a more predictive way because so far we were doing it in a more inferential way. To be a bit more predictive, we can use scikit-learn. Okay, so we're gonna divide our data frame into our data set into two parts. One part will be used for training, and the other part will be used for testing. Okay, so 600 of the 600 rows for the test, and the rest for training. So yeah, train and test, and we're gonna have them here. So it's based on the original XSOP that we had, the dataset with the featured engineering. Tim says OR larger than 1 means likely and OR less than 1 unlikely. Uh, it's actually the kind of effect that it has. If it's less than 1, it means that that property decreases the probability, and if it's higher than 1, it means it increases. The higher the coefficient, the stronger the effect in increasing. The smaller the coefficient, the stronger effect in decreasing. And if it's close to 1, it has almost no effect. Almost. Yeah. You're welcome. Okay, so we're gonna we have divided our dataset into two sets. One for train, one for test, and in both of them, we have that 20.8% of subscription rate. So let's use let's use scikit-learn to train our model. We're gonna have a scalar, which is gonna be a standard scalar, and we're gonna give it the test dataset. So train scaled equals scalar that fits transform train and test scaled equals to scalar that's transform b test. Okay, we're gonna scale these. Then we're gonna fit the model. We're gonna have a logistic regression. These are actually some variables you set for training your model. Actually, we can take a quick look on the documentation on this, although you don't have that much of the time. Okay, just so we here have defined maximum iterations and the random states. We're gonna see this together here. So let's see. Just a regression. I think I'm gonna explain this later because I'm in a rush to show you the visualizations that we can get out of this part, especially the confusion matrix that we have. So I'm gonna explain these later. CLFOR, and we're gonna fit on the data that we have scaled, and my train. Okay. Okay. What we want to predict is the test scaled. Okay. Our test data is just to check the predictions, and we know that for these data points, the probability is equal to 1. Okay. So if the model gets any of these x values in the test as an input, it always should return 1 as the probability. It is as if we are asking the model what's the probability of having this output. Okay, so just to check,
Skip this shit. this.
Okay, so we can see that we have successfully trained. We have 2,400 training samples and 600 test samples. So we're gonna have the confusion matrix here. Confusion matrix, and we're gonna have by test the first argument here is the true outputs of the model, and then we have our predictions. For the display the confusion matrix, the matrix is this one, what we have just defined here. And the labels, we're gonna say, okay, these are non-subs and subs, okay? And then we're gonna have matplotlib to draw us a plot. Fixed size comes to we're gonna use blue as usual. Let's just okay. So here we have the confusion matrix. It shows us true labels, and these are predicted labels. To check the number of true negatives, false positives, false negatives, we can humbly ask scikit-learn to give us the values. Meanwhile, I would like to ask you to calculate them if you remember the exact formulas from the previous sessions. While I'm just writing the printing functions here, I'm just gonna be a bit slower for you guys to write down in the comment sections. True negatives, we have correctly predicted non-subscribers. True negatives. False positives, those we have predicted as subscribed, but they're not actually subscribed. False negatives, those we have predicted as not subscribed, but they were actually subscribed. And at the end, true positives, those we have predicted as subscribed, and we were actually right about them. Okay, anyone willing to give us any answers before we run the code? It's kind of a
Yeah.
So if we want to have the accuracy, accuracy equals to everything that we have evaluated as true divided by all of them, which is 600. So our accuracy is around 80%. And if we want to have recall is everything that we have successfully evaluated as positive divided by all of the predictions. So all true positives and false negatives. Our recall is 70.6%. And finally, precision is all the true positives that we had divided by all true positives and false positives. How precise were we?
Sure.
60% precision. Not too bad for numbers. Yeah, not too bad. Yeah, I just wanted to show them that you can do the same thing, use it scalar, scikit-learn, gives you the exact numbers here and much more details. And ultimately, okay, we still have 5 minutes. I'm happy. At the end, we're gonna see the ROC curve. The ROC curve to see how our model is doing in general, changing the coefficients. So false positive rate and true positive rates are going to be given to us by a really generous function called ROC curve. We don't need to do any sort of calculation ourselves. I just did all this here just to be a reminder on the formulas. And zero, yeah. And area under curve is, again, we have a function for that. We're going to use y test and y. And we're going to show them using a plot here, which I won't be writing the code again because we have written code for visualizations multiple times so far. So you already know the drill. Too many values. What is that? What is expected to that 3. I have. Okay, let's have a dummy here. Okay. Okay, so this shows our logistic regression performance and the random classifier that we have. Random classifier is like flipping in a coin, and our logistic regression to performance is this. So AUC is 0.7, which gives us a bit of promising number. It's not really precise model, but it does just well. Okay, any questions, guys? No questions? Everything is clear? Okay, I assume everything is clear. Is there anybody in the class who's lost along what we were doing? Can you tune hyperparameters of logistic regression? Well, yeah. Yeah, I just wanted to say the same thing. Like, it's not that much of a complex model. We have like 17 columns, out of which only 3 of them are engineered features. 3 or 4 of them are engineered features. So there's not much that we can do. But if you're curious, you can play with these numbers that we have set here. Okay, yeah. So if you've already been doing it, yeah, you've seen enough to, yeah, to know that, yeah, latest regression is hard to beat. Okay. Cool. Yeah, significantly worse generally across the board without tuning, I find. Except maybe Gaussian. Interesting. Cool. It's actually encouraging to see you guys that you've spent some time digging more, exploring more. That's really encouraging. Okay, so your assignment is extended by the end of Sunday, July 5th.